Hello, I'm Chen Shaohua. Today I'm going to share my CTP final presentation. I will introduce my project, which explores how generative AI can support Hong Kong Sign Language. HKSL has its own grammatical structure, cultural background, and visual logic, but unfortunately, accessible learning resources remain quite limited. Traditional sign language teaching materials rely heavily on live action filming, which requires high production cost, careful setup, and long editing cycles. As a result, updates are difficult, and vocabulary expansion is low. With the rise of generative AI, new opportunity emerge. AI model can potentially create sign animations, enhance accessibility, and support interactive learning tools. This project investigates how AI can reduce cost, increase efficiency, and help preserve and promote HKSL. The project aims to explore how generative AI can support sign language learning in 4 key ways. First, reducing the production cost of sign language teaching materials by replacing filming with AI-generated animation. Second, enabling vocabulary expansion, including new or emerging slang that may not yet have formal HKSL equivalent, simulating AI-powered sign translation as a prototype for real-time communication tools. And finally, promoting wider HKSL awareness through a digital platform that is easy to access and continuously updatable. For the visual and UI identity, I designed a branding system centered on a hand-shaped motif, symbolizing sign language learning. Green was chosen as the primary color because it represents stability, knowledge, and a welcoming learning atmosphere. The platform is named HKSL Learn Plus. The plus sign signifies growth and enhancement through technology. I also incorporated a Victoria Harbour themed background to reinforce Hong Kong's cultural identity and connect sign language learning with its own context. The visual direction follows a clean, modern aesthetic built around head-shaped icons. I designed the interface in Figma, focusing on user-friendliness and clear navigation. The platform features 3 key components: an introduction to HKSL history, a sign vocabulary library, and an AI sign translation simulation. A 2-minute motion graphic was created using After Effects to introduce HKSL history from the 1960s to the 2010s. The design combines historical, accurate data with local color films. To maintain readability, I used the simple sentence structures supported by corresponding icons. Elements such as slicing timelines and large icons and highlighted keywords help reinforce memorability. AI-generated voiceover was added to create a cohesive and complete audio-visual experience. This slide shows the storyboard and script used to plan the flow of the motion graphic. During the development of the vocabulary database, I completed different AI tools, including HeyGen and Grok. HeyGen produced stylised characters but lack precision in hand-shaped details, which are essential for sign accuracy. Grok, on the other hand, generated more accurate hand motions and realistic body proportions. Because of this, Grok became the primary tool for sign animation generation. Grok produced more natural movement, but generating accurate sign animation was still challenging. Sign language depends on highly precise visual details, such as finger configuration, orientation, and movement speech. AI models have difficulties understanding this from brief text input. Early prompts, written in Chinese to generate a sign for dog, failed because the AI could not interpret the movement clearly. To improve precision, I switched to English prompts and used step-by-step descriptions. This significantly increased accuracy, especially when specifying hand shape, movement count, and facial expressions. For the sign dog, I described the curved downward-facing hands, the free up and down movements, and the barking-like mouth action. After several revisions, Grok finally produced output that matched official HKSL teaching videos. I also explored how AI can generate HKSL versions of slang, which often lack standardized signs. Two slang terms were texted in Cantonese, Dai Din, meaning super crazy, Dai Din meaning super crazy, and Ling Jun meaning no respect. For super crazy, the AI initially misunderstood the expressions. Editing emotional cues like angry and confused facial expressions helped match tone and meaning. The refined prompt produced more accurate results. For no respect, the sign required expressing the idea of withdrawing respect. The design used special metaphors, the left hand representing status and the right hand withdrawing support. The generated animation captured this efficiently, showing how sign language uses space and movement to convey metaphorical meaning. SignJammer, shown in Figure 11.1, is an open-source model that uses key point detection and visual language modeling to recognize sign language. One of its major advantages is that it works standard camera rather than requiring specialized sensors. At the moment, SignJammer supports only American Sign Language. However, because the model is open source, there is strong potential for future training on HKSL, especially if local datasets become available. Although this feature is not yet included in the current prototype, my technical investigation into SignJammer provides an important foundation for future development. To visualize how such a system might eventually work, I created a simulated interface in After Effects, shown in Figure 11.2. This mock-up demonstrates how a real-time HKSL translation tool could function in the future. For user testing, I invited 3 participants with different backgrounds to understand how effective and accessible the platform is. The first participant was a 65 years old with no sign language or digital experience. He was able to learn the basic functions very quickly and found the interface simple and accessible. The animation helped increase his interest in HKSL, showing that the platform is friendly even for beginners and older users. The second participant was a media technician in his 30s. He commented that Grok's animations look more modern and clearer than traditional sign language videos. He also found the slang content especially creative and appealing for younger learners. The third participant was a social worker with basic HKSL knowledge. He found the animation clearer for observing hand details and appreciated the real-time translation interface demo. He believed that, in the future, this type of technology could help improve communication with deaf clients in professional settings. Overall, user feedback shows that generative AI can reduce production costs, support cultural relevant vocabulary building, and encourage linguistic innovation through slang generation. All 3 features, The HKSL history section, the vocabulary library, and the translation demo were found useful by different types of users. Although real-time translation is not yet technically feasible, the simulation successfully illustrates the direction for future development and helps users imagine what the next steps could look like. The project demonstrates several strengths. First, AI greatly reduced the cost and time required to create sign language materials by replacing filming with prompt-based animation. Second, the vocabulary library includes both standard signs and AI-generated slang, making the learning content more relevant to everyday life. Third, the real-time translation demo suggests that AI could eventually support communication in social work, healthcare, education, and public services. However, there are limitations. The lack of HKSL datasets reduces animation accuracy, and generative AI output remain unstable, requiring repeated prompt refinement. Tools evolve quickly, and free versions have limited features. Real-time translation is not yet feasible until dedicated models such as SignJammer for HKSL become available. Through this project, I gained a deeper understanding of generative AI, particularly in prompt design, animation generation, and model behavior. Repeated testing taught me how to guide AI to interpret detailed sign components such as hand shape, orientation, positioning, and facial expressions. While current AI cannot fully analyze sign grammar, future advancements, and especially open-source HKSL dataset may support broader applications. AI has strong potential to enhance accessibility for deaf communities, improving communication in public services, education, and daily life. Looking ahead, future development goals include improving motion quality, expanding the vocabulary database, integrating real-time translation, and establishing a system for continuous update. Collaboration with HKSL instructors will also be essential to ensure accuracy, cultural authenticity, and respect for the deaf community.
By selecting the History of HKSL button, you can watch a 2-minute introduction to the history of Hong Kong Sign Language.
Since ancient times, sign language has been the most natural form of communication within the deaf community. A major historical turning point occurred in 1880 at the Second International Congress on Education of the Deaf in Milan, Italy.
The second function is the vocabulary database, where you can choose different categories and learn sign language movements through animated tutorials. You can also use the search function to enter the vocabulary you want to learn, such as super crazy. The goal is to keep up with current Hong Kong slang trends and make the learning platform more up-to-date. Finally, the live translation feature allows the AI to translate immediately based on real-time sign language movements.